If you are evaluating cloud security platforms, you have probably noticed a shift from pre-deployment scanning to protection that works in real time. This review focuses on Suite Security, a vendor that positions its platform as a runtime-powered CNAPP, or Cloud-Native Application Protection Platform. The central idea is simple. Watch applications, infrastructure, and identities as they operate in production. Correlate signals across your cloud estate, and respond to active threats quickly and with context. Let's start with what runtime-powered means. Traditional tools scan infrastructure as code templates, look for misconfigurations in your cloud control plane, and check container images and packages for known vulnerabilities before deployment. Those are essential capabilities, but they primarily surface potential issues. Runtime-powered CNAPP complements that by observing what is actually happening now, tying detections to live processes, network flows, and identity actions. That real-time view helps teams see exploitation, lateral movement, or data exfiltration attempts, even if an issue slipped through testing or a zero-day vulnerability exists with no patch available yet. Buyers naturally ask whether Suite Security uses AI. In cloud security, runtime analytics commonly apply machine learning to establish baselines of normal behavior and surface anomalies with higher precision. The value is not just detecting something unusual, but connecting it to a broader chain of evidence. Which container initiated the connection, which Kubernetes service account or IAM role was used, what policy allowed the action, and whether the workload is internet exposed. When you evaluate a runtime-powered CNAPP, ask for details about the detections, training signals, explainability, and how alerts map to frameworks like MITRE ATT&CK to help your analysts act quickly. What capabilities should you expect from a runtime-first CNAPP? First, cloud workload protection for containers, Kubernetes nodes, and virtual machines that can observe process, file, and network activity and enforce guardrails. Second, Kubernetes runtime visibility to monitor namespaces, pods, cluster roles, and admission events, and to identify risky behaviors like container escapes, outbound command and control attempts, or suspicious privilege escalations. Third, posture management and configuration analysis for your cloud accounts that prioritizes findings based on runtime exposure, such as whether a vulnerable workload is reachable from the internet and actively receiving traffic. Fourth, identity intelligence similar to CIEM, highlighting excessive permissions and risky role assumptions, then correlating them to runtime activity that indicates abuse. Finally, detection and response workflows that integrate with SIEM and SOAR tools, ticketing systems, and collaboration platforms so incidents move through your process efficiently. How do these capabilities deploy? A runtime-powered platform typically ingests cloud-native telemetry, AWS CloudTrail, VPC flow logs, and services like GuardDuty, Azure Activity Logs and Defender for Cloud, Google Cloud Audit Logs and VPC flow logs, plus Kubernetes audit logs. Many solutions complement this with lightweight sensors at the node or container level, often implemented with technologies such as Linux eBPF to capture system calls and network events with low overhead. Some buyers prefer agentless models that read cloud APIs and workload metadata. Others select a hybrid approach to combine breadth of visibility with deep runtime context. The right choice depends on your risk tolerance, performance requirements, and operational model. Let's talk about outcomes. The strongest benefit of runtime context is prioritization. Most cloud programs struggle with alert fatigue. By linking a misconfiguration or a known CVE to an actively running process that is reachable from the internet and making suspicious outbound connections, a runtime-powered CNAPP can elevate the right issues and suppress noise. You get fewer, higher-quality alerts that come with the who, what, where, and how, the container image and tag, the Kubernetes namespace, the IAM role or service account, the source and destination IPs and ports, and the exact timeline of events. Organizations also look for coverage across architectures. If you run Kubernetes on EKS, AKS, or GKE, you will want visibility into control plane events, admission control, network policies, and workload behavior. If you rely on serverless functions, you need context around invocation patterns, permissions in IAM, and data access. For traditional VMs, process and network monitoring help surface living off the land techniques that may not trigger signature-based tools. Across all these, correlation with cloud control plane changes provides the full picture. Integrations matter. A platform is more valuable when it fits your workflows.
Look for ingest options into your SIEM, whether that is Splunk, Elastic, Chronicle, or Microsoft Sentinel. Check SOAR playbooks to automate containment steps like isolating a pod, revoking a role, or blocking an egress destination. Ticketing integrations with Jira or ServiceNow keep remediation on track, and chat apps like Slack or Microsoft Teams help notify owners of affected services. Also review API coverage for pulling findings into your data lake or custom dashboards. How should you evaluate pricing? Expect a SaaS subscription model, typically tiered by workloads or nodes, protected cloud accounts, data volume, and retention. Enterprise buyers often need SSO, granular RBAC, audit logging, and support SLAs.
The most reliable way to compare cost is a formal proof of concept with a defined subset of accounts and clusters. Clear success metrics, such as mean time to detect for known attack simulations, and a written bill of materials that lists every cost driver, including additional storage or retention if needed. How does a runtime-powered CNAPP compare to other market options? Vendors like Wiz, Palo Alto Networks Prisma Cloud, Orca Security, Lacework, and CrowdStrike Falcon Cloud Security each bring different strengths. If the center of gravity in your program is compliance reporting and posture breadth, you might gravitate toward posture-led platforms. If your main pain is active threats in production, runtime-first capabilities can shorten investigation and response times. In practice, many organizations combine shift-left scanning, strong posture management, and runtime detection to close gaps at every stage of the software lifecycle. Who should prioritize a runtime-first approach? Teams that run microservices at scale, maintain business-critical APIs, or operate in regulated industries benefit from live context and faster triage. If you are investing in Kubernetes and need to detect container escapes, suspicious daemon sets, or risky service account use, runtime visibility is essential. If 0 days keep you up at night, having detections that spot exploitation patterns before patches are available adds resilience. And if your executives want clearer risk reduction metrics, correlating vulnerabilities and misconfigurations to active exploitation attempts provides compelling evidence. Before you buy, prepare a checklist. Confirm multi-cloud coverage across AWS, Azure, and Google Cloud. Validate Kubernetes support in EKS, AKS, and GKE. Ask about data residency and encryption. Measure performance overhead if sensors are deployed, and confirm that agentless options exist where required. Review how detections are explained, how false positives are handled, and how quickly new threat techniques are added. Finally, test integrations with your SIEM, SOAR, ticketing, and on-call processes so the platform fits into your day-one operations. In summary, Smith Security's runtime-powered CNAPP strategy aligns with where cloud security is heading, augmenting preventive controls with real-time detection and response that understands how your workloads truly behave in production. If your goal is to reduce alert noise, accelerate investigations, and catch threats as they happen, put runtime context at the top of your evaluation criteria. Combine it with strong shift-left practices and posture management, and you can materially improve cloud risk outcomes without drowning your team in signals.